Welcome to Stephen's Academic Training Center. Yeah, so today I want us to look at cost of electricity. This is physics and the cost of electricity. So when we talk about cost of electricity, we need to make sure that when finding the cost of electricity, we need to take note of the following. The first one is the formula for energy, which is energy is equal to power times time. So this energy, we all know that energy is measured in joules. Yeah, then the power need to be in kilowatt. So don't forget that when finding cost of electricity, in any normal calculation, the power must be in watts, but only on cost of electricity, the power need to be in kilowatt. So if the power is given in watts, table means to convert it in kilowatt. And we know that 1 kilowatt is equal to 1000 watts. So you need to know that 1 kilowatt is equal to 1000 watts. So only on cost of electricity, the power need to be in kilowatts. But in any normal calculations, the power is supposed to be in watts. But on cost of electricity, the power is supposed to be in kilowatts. Then times the time. The time here, the time need to be in hours, only on cost of electricity. But in any normal calculation, the power need to be in seconds. I mean, the time need to be in seconds, but only on cost of electricity, the power need to be in what? In hours. So this energy that I'm talking about, this energy. So this energy, which is equal to power times time. This energy same as unit. So this energy represents units. So the energy represents units. Don't forget that this energy same as units. So when I say 1 unit, which means I mean that 1 energy is equal to whatever number given. Then apart from the formula for energy, if one can also say energy is equal to power times time, which is same as this formula. Apart from this, you can say energy is equal to V squared over resistor times time. This is also the formula for energy as well. This first formula, second formula. The third one is energy again is equal to I squared resistor time as well. This is also a formula for energy. Apart from that, you can say energy again is equal to VIT. So this is also another formula for what? For energy. Then if I want to find power, I can say power is equal to VI like this. Okay, power is equal to VI. Apart from that, I can say power is equal to I resistor like this. Again, power is equal to V squared over resistor. So all these are the formulas for power. So these are formula for power. Don't forget this formula, very important. Apart from that, don't forget this formula, which is a resistor is equal to voltage over current. And also the other one is a charge is equal to IT, current times time. So this one, another formula. So these formulas are very, very important. Yeah. So now back to the cost of electricity. So as I said, for example, like if they say 1 unit, one unit cost maybe 5 kwacha like this, which means this unit here is present in this energy, which means here I need to find energy. This is supposed to be energy here is equal to the amount given that amount that I'm calculating. So you need to know how much is per unit. So 1 unit which represents energy is equal to this 5 kwacha. What about this one? Which means here I need to find energy because 1 unit is same as energy. So don't forget that 1 unit is same as energy. So I'll do some questions on this part. Yeah, so I have question number 1 here. Question number 1, hope it's clear. So the question read, a 12 volt battery is giving off a current of 2 amps, okay, to a resistor. Find the power dissipated in the resistor. So they want to find the what? To find the power. So as you can see, the current is given and the voltage is given. So we need to choose the formula to use. So here, I'll use this formula. I'll say power is equal to, since I have voltage, so I use since I have voltage and current. So which formula I've got voltage and current? So I'll use power is equal to V times current like this one, this formula. So my power is equal to, my voltage is 12 volts, then times current is what? Is 2 amps here. Okay, then I need to multiply. So power is equal to 12 times 2, which is 24 watts. So this is my power for this question. Okay, this power for this question. Then I'll go to question 2. Question 2 also read, a PD of 12 volts is applied across the 4 ohm resistor. Find the power. So as you can see, in this question, I have voltage here, this voltage, and this resistor. So I need to come up with a formula to use. Remember, I mentioned a little formula for power. So on this one, I'll use the power is equal to V squared over Z resistor. Since remember, I have voltage and resistor here. So now I'll say power is equal to, my voltage here is 12 volts. Remember that the square here, then over the current, the resistor is 4. So now I'll continue solving. I'll say power is equal to, this is 12 times 12 over the 4 here. So again, I'll say power is equal to 12 times 12, which is 140, 144 over 4. So now I'll divide with the calculator, which is 144 divided by 4. Answer is 36. So power is equal to 36 watts. This is the answer for this question. Okay. Then I'll go to question 3. Question 3 read, if electrical energy cost per unit, which means pay attention here. If electrical energy costs 50 kwacha per unit, so which means 1 unit, which is energy, cost how much? Cost 50 kwacha, like this. Okay. Then now, what is the total cost of using 100 kilowatts? So this 100 kilowatt is energy, because I say that energy is equal to power times time. Then the power must be in kilowatt like this. Then time need to be in hours. So which means this will have kilowatt hour, which is energy. So energy will have energy, which is what? Which is 100. So it means I'll put which is 1,000. So I'll put here 1,000 here, like this, which is my energy. Then to here the amount is x, which means I need to now to find x here. So cross multiply. So 1 times x, it will be x is equal to so it will be now 50 times 1,000. So x it will be 50 what? 50,000 kwacha here. So this will be the amount of money that's needed in this question. Okay, so I'll go to the next question, question number 4. Question number 4 read. A light bulb, hope it's clear, a light bulb of 100 watts is used for 7 hours. What the energy cost if the energy costs 50 kwacha per unit? So which means again I'll say 1 unit cost what? It costs 50 kwacha again here. Okay, 1 unit cost 50 kwacha. Okay. Then now, what's the energy cost of the energy? So a light bulb of 1000 watts is used for 7 hours. What's the energy cost? So it means we're finding for money here, which is X here. So put X here. Then we need to find energy. So we know that energy is equal to power times time. I remember what I said. I said the power need to be in what? The power need to be in kilowatts. So this power is in watts. So convert this power into kilowatts. So we'll say 100 over 1,000 because we're converting into what? Into kilowatt. Then times the time given is already in hours. So I'll just put 7 hours here. Okay. So 100 divided by 1,000, it will be 0.1. Then times 7. So 0.1 times 7. What will be the answer? So 0.1 times 7. The answer is 0.7. 0.7. So 0.7. So this is my energy here, which is 0.7. 0.7. Okay. So now I'll put the 0.7 here. 0.7. Then I'll cross multiply. So 1 times x will be x. So 0.7 times 50. So it will be x is equal to. So 0.7 times 50. The answer is 35. So it is 35 kwacha. That will be the answer for this question. Okay. Then again, I'll go to the next question, which is question number 4. 4 security lights of 120 watts are turned on for 30 days. So this 30 days need to convert to what? To hours. What the energy cost if it costs 60 watt per unit? So I want you to try this one. And don't forget that there's the 4 security light. So the lights are 4. So it means this power need to be multiplied by 4 times 120. That will be how much? That will be 480 watts. Yeah, then again, we need to convert this days into hours. So 30 days times 24 hours in a day. So after finding the answer now, you say 1 unit is equal to the quarter given, which is 60 quarter. Then what about the energy that we're going to find here on this side? Put x on the other side. So I want you to try this one as a part of exercise. Thank you very much.